I'm John Cox, and this is my Physics 2212 Lab 4 about circuits. Lab overview is to predict circuit behavior for series and parallel resistor configurations. Measure current voltage using multimeters. Analyze ohmic resistors and capacitor behavior. Core principles, conservation of energy and charge. Node and loop rules. Ohm's law and steady state analysis. Time-dependent RC behavior. Key findings measured values aligned with theoretical predictions. Current magnitude in RC circuits proved to be time-dependent. Model and assumptions. Resistance of wires is negligible. EMF equals delta V of the capacitor plus delta V of the resistors. Experiment part 1. Series circuit setup. Two batteries power a series circuit containing two resistors, 2 amp meters, are placed to verify the current remains constant. 2. Amp meter readings and observations. Measured readings plus 0.02 amps. Current flows as predicted. Reversed plus minus 0.02 amps. Ammeter flipped, signs inverted. Voltmeter swap, 0 amps. Open circuit created no current flows. Part 3. Potential difference along the circuit. Voltage profile A to H. Labeled nodes A through H map the potential around the loop. The voltage graph shows a sharp rise across the battery. A plateau stepwise drops across 47 ohm and 100 ohm resistors, confirming the voltage law. Sum of all potential changes around the loop equals 0. Part 5. I introduced a capacitor. System. The circuit itself. Surroundings. Everything external through the circuit. Conditions. 10 and 20 ohm bulbs. 9-volt battery as the power source. 200 mF capacitor in series. Part 6. Charging and discharging. With the battery connected in series with a bulb and capacitor. The bulb brightens initially and fades as the capacitor charges. On disconnect, the stored charge drives current in reverse. The bulb briefly re-illuminates before dying out completely. 10S, 10 ohm charging. 12 seconds, 10 ohm discharging. 17 seconds, 20 ohm charging. 22 seconds, 20 ohm discharging. Higher resistance slows both charging and discharging. Part 7. RC circuit model. Circuit parameters. Capacitance C equals 1 ohm. Resistance R is 47 ohms. Time constant. The RC time constant RC equals 47 seconds covers how quickly the capacitor charges and discharges. After one time constant, the capacitor reaches 63% actual charge. Sources of error. Primary considerations. This lab used an ideal computer simulation. Most common sources of error. Component tolerances, contact resistance, thermal drift were eliminated by design. Human error was the only substantive source of inaccuracy. Incorrect. Misreading instruments, incorrect wiring, timing errors, etc. In the physical lab, non-ideal component behavior would introduce additional error. Real-world considerations. Real ammeter versus ideal ammeter. Physical ammeter carries a small but non-zero resistance. When inserted into the circuit, this added resistance would slightly reduce the measured current, causing readings to fall just below the predicted ideal values. Charging a capacitor without a resistor. An ideal model predicts instantaneous charging with zero resistance in the loop. In reality, every wire and battery has internal resistance. Capacitor would charge rapidly but not instantaneously in a dangerous surge. Thank you.